Good morning. Welcome you all in this our subject Mechanical Engineering Materials, whose subject code is 22343, and I am in Bilandgi. Friends, as you know, we are in a chapter non-metallic materials and advanced materials. So friends, up to previous lecture we have discussed different non-metallic materials. So as you know, non-metallic materials means materials other than the metals. And friends, these four types of non-metallic materials we have discussed in detail. So in which first is polymer, means plastic. So what is my plastic? Types of plastic, different applications of plastic, properties of plastic, day-to-day life applications. So all this part we have discussed about the polymer or plastic. After that we have discussed rubber material. Then after that we have discussed ceramic material. Day-to-day life ceramic applications also we have discussed. After that, what are my composite examples of composite material we have discussed. Correct, na? So friends, in today's lecture we are going to discuss about the advanced materials. So in advanced materials, nano and smart material we have to discuss in detail. So friends, first see here what is my advanced material. So meaning is very clear. Advanced materials are the such material those are used in high technology applications. Nowadays in high technology applications materials are used called as advanced materials. So these are the such material whose properties are better than the other one. That's why these materials are used in high technology applications. So as per technology, nano and smart, these are the two advanced materials are there. So friends, first here what is the smart materials. So smart materials are also called as an intelligent material. So what is my smart material? Smart materials are the such material which shows one or more properties by changing properties such as stress, moisture, electric or magnetic field, light, temperature, pH or the chemical compounds. Means smart materials are such material whose internal properties goes on change by changing external parameters such as stress, moisture, temperature, light, likewise. Means smart materials are the such material whose internal properties goes on change by changing external parameters like moisture, temperature, humidity, pH, stress, likewise. So clear what is smart materials, friends? Smart materials are the such material whose internal properties are depend on or internal properties goes on changes by changing external property like moisture, temperature, light, likewise. So friends, there are different smart materials are there. So one by one we have to discuss those. So first, piezoelectric material. So piezoelectric materials are materials that produce a voltage when stress is applied. What is my piezoelectric material? These are the such material which produces voltage when stress is applied. So what is my piezoelectric material? Piezoelectric material means if we apply the stress on that material, voltage get produced in that material. That is piezoelectric. Then photovoltaic material. Photovoltaic materials are the materials that convert light due to the electric current. So photovoltaic materials are the such material in which due to the electric current light energy get produced. Correct na? Then electroactive polymers. So electroactive polymers are the such material whose volume gets changed by voltage or electric field. Means electroactive polymers are the such material whose volume gets changed by changing in voltage or electric field. Means due to the change in voltage or electric field, volume of those material gets changed. Then shape memory alloy. Shape memory alloys are the such material which remember their original shape when these material are bent or twisted from their original shape. What is my shape memory alloy? Shape memory alloy are the such material. These are the such smart material, or these material remember their original shape when this material gets bent or twisted from the original shape, and this material gets reoccupy their original shape and size when heated up to the certain temperature. Shape memory alloy, these are the such material, they reoccupy their original shape when heated up to a certain temperature. The next material, magnetostrictive. So magnetic strictive material are the such material which exhibit change in a shape when magnetic field is applied. So magnetic strictive material are the such material in which due to the magnetic field, shape of this material gets changed. Magnetostrictive material are the such material in which due to the magnetic field, shape of this material goes on changes. Then magnetic shape memory alloys. So magnetic shape memory alloys, these are the such material which change their shape when magnetic field is applied. So magnetic shape memory alloy are the such material in which due to the magnetic field, shape of these material get changed. Means in magnetic shape memory alloy material, if you have to change the shape, what we have to do? We have to introduce the magnetic field. Then pH sensitive polymer. So pH sensitive polymers are the material that change in volume when pH of surrounding medium changes. So pH sensitive polymers are the such material in which due to the change in pH of the surrounding medium, volume of this material gets changed. Then temperature responsive polymer. So temperature responsive polymer are the such material whose properties undergo changes due to the change in temperature. Temperature responsive polymers are the material whose properties undergo change due to the change in temperature. Then after that, electrochromic. So electrochromic are the material which change their color on the application of voltage. So electrochromic are the such material in which due to the change in voltage, color of this material goes on changes. Then thermochromic. Thermochromic means these are the such material in which due to the thermal energy, due to the heat energy, color of this material goes on changes. Chromic means color change. Thermo means due to the heat. So due to the temperature, color goes on changes, called as thermochromic. Then photochromic, very simple meaning is there. Photochromic, due to the light rays, color of this material goes on changes. Photochromic are the material which color goes on change due to the light. Photochromic means due to the light rays, color of this material goes on changes. Photochromic. And day-to-day life example of photochromic material is already familiar with us. We know sunglasses. In goggles, sunglasses are used. Sunglasses means glasses having the different colors. And if we observe those glasses, that glasses darken or light sensitive glasses are there. So due to the light, these glasses takes a color dark. Correct, na? So called as photochromic. Due to the light rays, color goes on change. Example is familiar with us, sunglasses. Means due to the light rays, color of these glasses goes on changes. And at last, photomechanical material. Photomechanical materials are the such material in which shape of this material goes on changes due to the light. Photomechanical. Photo means light rays. So due to the light rays, shape of this material goes on changes, called as photomechanical. So clear? In smart material, if we change external property, according to that, internal property goes on changes. Then friends, what is nanomaterial? So in nowadays, in research work, generally these nanomaterials are used. So nanomaterials are the materials that are manufactured and used at very small scale, called as nanoscale. Later on we have to discuss what is nanoscale. So nanomaterials are developed to exhibit novel characteristics compared to the some material without nanoscale features, such as increased strength, chemical reactivity or conductivity. Means nanomaterial having the better properties than the other general materials. Means nanomaterial have better properties like strength, chemical conductivity, chemical reactivity, and many more properties are better in nanomaterial than the other conventional material. That's why these nanomaterials are used in research work. So as per ISO or TS 80004, nanomaterials are defined as the materials with any external dimension in the nanoscale or having internal structure or the surface structure in nanoscale, with nanoscale defined as the length range approximately from 1 nanometer to 100 nanometer. So as per standard, nanometers or nanomaterials are the such material whose internal and external structure it is in nanoscale. Nanoscale means it is very small scale. So friends, here nanometer. So 1 nanometer means 10 raised to minus 9 meter. Students, always keep in mind, 1 nanometer means 10 raised to minus 9 meter. Means students, here very small dimension is there called as 1 nanometer. Now with the help of this relation we can imagine this. 1 nanometer means 10 raised to minus 9 meter. Means students, what do we have to do? We have to take a 1 meter. 1 meter distance or 1 meter scale, it is familiar with us. What do we have to do? We have to take a distance of 1 meter. Then 1 meter we have to divide into 10 raised to 9 part. What do we have to do? 1 meter we have to divide into 10 raised to 9 parts, and belongs to those 10 raised to 9 parts one part called as 1 nanometer. Now we can imagine how precise, how accurate dimension, how small dimension is there called as 1 nanometer. So properties of nanomaterials. These materials have higher thermal conductivity than the metals. Means thermal conductivity of nanomaterials are good. Then second property, few nanomaterials shows a different color when they are converted into nanoscale. There are some materials are there which shows different color when they are converted into nanoscale. Then they have better mechanical strength and hardness. Means nanomaterial have good mechanical strength as well as hardness. Then nanomaterial have relatively lower melting point. Means nanomaterial melts at lower temperature. Then students, see here, these are the different application of nanomaterials. Paints, cosmetics, in textile and fabric industry nanomaterials are used. Electrical applications, pollution control applications, automobile and aerospace applications in which nanomaterials are used. So friends, nowadays these nanomaterials and smart materials are widely used in research work, in advanced work due to its better properties. So friends, likewise, in today's lecture we have discussed advanced material and smart material in detail. And likewise, we have concluded this whole chapter called as non-metallic and advanced material. So friends, in next lecture we are going to start next topic called as cast iron. So what is by cast iron? Types of cast iron, according to the type, applications of cast iron, that we are going to discuss in next lecture in detail. So okay friends, thank you very much.